This is Dr. V. Naganjanelu, Associate Professor, Department of Mathematics, Vardhaman College of Engineering. Course is Matrices and Calculus, and present topic is evaluation of triple integrals. Evaluation of triple integrals. In two ways you can evaluate. One is one variable within the limits of another variable, like x in limits in y in limits x, and z is constant, or interchange you can do that. And another one is all limits are constants. If all limits are constant, then order of integration is immaterial. Choice is yours. Look at the case 1. x1, x2 are constants I have taken. y1 or y2 are functions of x. And z1, z2 are the functions of x and y. Means z is a function of xy, y is a function of x, and x is a limit. X limits are constants. You may take reverse also. Z constant, y in x and x in yz. Choice is yours and depends on the problem. Look here. x1, y1, z1. Limit x, y, z. I am going to change first constant, then single variable y in x, and then z in x and y. Let's see. I am solving two types of problems. One is all limits are constant. Another one is some limits are constant, remaining are in variables. Problem 1. Evaluate integral 0 to 1, integral 1 to 2, integral 2 to 3, x square y cube z power 4 dx dy dz. So by seeing this, it is under evaluation of triple integral and all limits are constants. So choice is yours. Whatever you want to take, x, y, z is your choice. Coming to solution, triple integral 0, 1, 0, 1, 2, 2, 3 is x square y cube z power 4 dx dy dz. I am going to take this as it is. Now I have dx here, so that I am preferring first one is x, and dy is there, second one is y, and dz is there, the last one is z. It's my choice, but according to the properties you may take whatever the order. It is random. Now integral, I am taking this as x is 2 to 3, and I am taking this as y is 1 to 2, and we are getting z is 0 to 1. Let's make x square y cube z power 4 dx dy dz. And luckily here the product is available in between three variables. You can separate the integration. If suppose product is not there and plus is available, then first you do with respect to x, then with respect to y, with respect to z, you have to do that. When plus is there, those will act as independent. When product is there in among these variables, those will act as dependent. Separate this. Z is 0 to 1 and z power 4 dz. Y is 1 to 2 y cube dy. X is 2 to 3 x square d. Now what is this integration? Z power 4 dz will become as z power 5 by 5 0 to 1, and this integration will become y power 4 by 4 1 to 2, and the last integration will become x cube by 3 2 to 3. Okay. Now substitute upper and lower limits. We get 1 by 5 is outside, 1 minus 0, 1 by 4 is outside, 2 power 4 16 minus 1, and 1 by 3 is outside, 3 cube 27 minus 8. You'll get it as 1 by 5, and by simplification this is 15 by 4, and by simplification 27 minus 8 gives 21 by 3. Now do the cancellation. You will get 5 3's, and this 3 will cancel, and you are going to get 21 by 4. Coming to second problem, evaluate integral 0 to 1, integral y square to 1, integral 0 to 1 minus x dz dx dy. You will get like integral 0 to 1, integral y square to 1, integral 0 to 1 minus x dz dx dy. Please identify the limits. Look at here. The first integration having x limits and second integration having y limits. So if I take this is z, then it must be x. then last one is z. Hope you understand. You may question me, why can't I take this is a y? If you take y here, already y is repeating here. So that first integration must be how to take z, then z over, then xy left, y is available, y square is available, so x is possible, then x left, then last one is z, then last one is z taken, y taken, the last one is you are going to get y. Okay, evaluate this. You will get integral y 0 to 1, integral x is y square to 1 and z dz. So you are going to get x as it is and z, and the limits are substitute 0 to 1 minus x dx dy. Then go for the next integration. You will get y is 0 to 1 and x is y square to 1, x into upper limit is 1 minus x dx dy. Multiply this, you will get y is 0 to 1 and x is y square to 1, x into 1 x minus x square dx dy. The next you are going to get integral y is 0 to 1 and x dx will become x square by 2 minus x square dx will become x cube by 3, and the limits are x is y square to 1. Y square to 1 will get dy. First z eliminated, then x is about to eliminate, at last y. Substitute, you are going to get integral y is 0 to 1 and 1 by 2 minus 1 by 3 as upper limit minus lower limit is y square whole square, y power 4 by 2 minus y square whole cube, y power 6 by 3 dy. Now 1 by 2 minus 1 by 3 LCM is 6 and 3 minus 2, so you are going to get 1 by 6. Integral y is 0 to 1, 1 by 6 minus y power 4 by 2 plus y power 6 by 3 into dy. Now it's time for evaluating y. Equal to 1 by 6, you are going to get like this. 1 by 6y minus 1 by 2, y power 4 dy becomes y power 5 by 5 plus 1 by 3 is a constant, y power 6 dy becomes y power 7 by 7. And the limits are, you'll get 0 to 1. Let's substitute that. You'll get it as 1 by 6 minus 1 by 10 plus 1 by 21. Now you simplify that. You may use calculator or whatever. So by using calculator or take the LCM and you work out. This answer is 4 by 35. Thank you.